Assalamu alaikum and welcome back to Chemistry World, and I'm your instructor WAHAJ Khalil. Today's the topic of our lecture is ferromagnetic materials. All about ferromagnetic materials are included in this lecture. So ferromagnetic materials are those materials which which exhibit a spontaneous net magnetization at the atomic level, even in the absence of an external magnetic field. A ferromagnetic substance contains permanent atomic magnetic dipoles that are spontaneously oriented parallel to one another even in the absence of any external magnetic field. So when placed in a magnetic field, the ferromagnetic materials are strongly magnetized in the direction of the magnetic field. Ferromagnetic materials are strongly attracted toward a magnet. So these materials will retain their magnetism for some time even after the external magnetizing field is removed. So this process and property is termed as hysteresis. Ferromagnetic materials, you may also elaborate in this way. Ferromagnetic materials are certain group of substances that tend to manifest or display strong magnetism in the direction of a field due to the application of magnetic field. So the cause of magnetism in these materials is mainly due to alignment patterns of their constituent atoms. Because of their alignment. So these atoms tend to behave as elementary electromagnets. Causes of ferromagnetism. In a ferromagnetic material, in a unmagnetized state, atomic dipoles in small regions called domains are aligned in the same direction. Atomic dipoles in small regions are called domains, and domains are aligned in the same direction. So the domain exhibit a net magnetic moment even in the absence of external magnetizing field. So the domain exhibit a net magnetic moment even in the absence of external magnet. So however, the magnetic moments of the neighboring domains are oriented in opposite direction. They cancel out, therefore the net magnetic moment of the material is zero. On applying an external magnetic field, these domains are aligned. Themselves in the direction of the applied magnetic field. In this way, the material is strongly magnetized in a direction to the magnetic field, external magnetic field. So we can elaborate it with a figure A. The atomic dipoles are randomly distributed, for example these. So these are domains before the applying of external magnetic field, and figure B is after the application of magnetic field, all domains are in a line. So after magnetization and random domain orientation. So, types of ferromagnetic materials. Ferromagnetic materials can be divided into two major types. Magnetically soft materials like annealed iron, which can be magnetized but do not tend to stay magnetized. So it is termed as soft materials. And magnetically hard materials which do permanent magnets are made from hard ferromagnetic materials such as alnico and ferrite that are subjected to special process in a strong magnetic field during manufacture to align their internal microcrystalline structure, making them very hard to magnetize. So to demagnetize a saturated magnet, a certain magnetic field applied must be applied, and this threshold depends on coercivity of the respective material. So hard materials have high coercivity, whereas soft materials have low. So the overall strength of the magnet is measured by a magnetic moment, or alternative the total magnetic flux is produced. So the local strength of the magnetism in a material is measured by magnetization. Examples of ferromagnetic materials. Most of the ferromagnetic materials are metals. Common examples of ferromagnetic materials are iron, cobalt, nickel. In addition, magnetic alloys and rare earth magnets are also classified as ferromagnetic materials. So, magnetite is a ferromagnetic material which is formed by the oxidation of iron to oxide into an oxide. So it has a Curie temperature of about 580 degrees Celsius. Earlier it was recognized as a magnetic substance. So magnetite has large great magnetism about all the natural minerals on earth. So this is our lecture about ferromagnetic materials, their properties, their examples, the causing of ferromagnetic ferromagnetism. And if you like that video, please share, subscribe, and don't forget to press the bell icon. Thanks.